Hi students, welcome to lesson 6.1, adding and subtracting polynomials. In this lesson, we're going to answer the question, how do you add or subtract two polynomials, and what type of expression is the result? So what exactly is a polynomial? Well, a polynomial expression is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable. So for example, if I had something like this, I'd have x cubed plus 2x squared minus 7. So there are three different terms there. 1, 2, 3. Terms are separated by additions and subtractions. And so that would create a polynomial because each of those is an algebraic expression, and it's the combination of them as a sum or a difference. Now, one of the things that is important to know about polynomials is that polynomials have to have only whole number exponents. And even if you have a constant term like this 7, this is like saying x to the 0 power. So that really is a whole number exponent. And so we're not allowed to have like fractional exponents or negative exponents. Those are different kinds of functions. So we would, if we had, let's say we had a variable as an exponent, well, that wouldn't be a polynomial function, that would be an exponential function. So to be a polynomial function or a polynomial expression, you have to be a combination of algebraic expressions with only whole number exponents. So what exactly is a monomial? Well, a monomial is just a single term polynomial. So if we just took any one of these, each one of these is a monomial on its own. But because we have three of these terms, this is actually called a trinomial. So again, we would define a monomial to be a single term polynomial. Now, how do we determine the degree of a monomial? I'm going to look at a couple examples. So here are three different monomials. X cubed is a monomial, x cubed y is a monomial, and 3abc is a monomial because they are all single term polynomials and they only have whole number exponents. So if I want to define the degree of a monomial, you basically will go to look at the exponents, and it's always the sum of the exponents on the variables. So in the case of this first one, there would just be a degree 3. In this next one, I have an x cubed, but I also have a y to the first. So in that case, it's the sum of the two. So this would be degree 4. And again, I just took the two exponents here, 3 and 1, and I added them, and I got 4. So that means in this final one, 3abc, each one of those has an exponent of 1 on it. And so my sum of those exponents would be 3. So this would also be degree 3, just like that first one. So that's how you find the degree of a monomial. You just take the sum of the exponents. Now, when you have a larger polynomial like we had in our original example, we actually find the degree of the polynomial by going to the highest degree term, and that's the degree of the polynomial. So again, we might define that as the highest degree of any term. So looking up at our example up here, say we went up here, we look at the highest degree term would be that x to the third. Well, and so that would be a degree 3, which we know is called a cubic polynomial. And finally, what is a leading coefficient? Well, a leading coefficient is the coefficient on the highest degree term. So if, for example, I had this polynomial, let's say I had x cubed minus 4x to the 5th plus 7x squared. Well, the leading coefficient is actually the negative 4. And this is actually not in standard form. In standard form, we'd want to switch this around, and we want to put that negative 4x to the 5th out front, and then we go down from there. So then we go to the next degree term, which is x cubed, and then 7x squared. And so then that leading term, leading coefficient, is actually on the highest degree, but it's also out in front. That's why they usually call it leading coefficient. And that's because if we put them in the right form or standard form, it will be the number out in front. So let's go ahead and take a look at some examples. So if we want to identify the monomials are the ones that are single term. So there's a single term polynomial, and let me see, there's another single term polynomial right there, and even this is a monomial. So all of these are the monomials here. So the x cubed, the a squared b c to the 12th, and even the 76. They are all just a single term, whereas this one right here, this one, that has 1, 2, 3, 4 terms. That's a 4-term polynomial, and so that would be, let's see if I can get a different color here. That's going to be the one that's not a monomial, that one right there. So again, this is just getting comfortable with terminology. So the degree of each monomial. So they listed out the monomials here, and let's tell the degree. Well, the degree of x cubed is, of course, 3. The degree of a cubed b c to the 12th, remember that b has a exponent of 1 on there, so that's 2 plus 1 plus 12, and that's 15. So that would be a degree 15 term. And then the x term and the 76 is really an x to the 0 power, so that's actually a 0 degree, a degree 0 term. Now when we say the terms of a polynomial, we mean each individual thing. Each one of these separate things is a term. So y is a term, 3y squared is a term. So I'm having trouble with my stylus today. Negative 5y squared, or y cubed, excuse me, is a term, and then 10 is a term. Those are all separate terms of that polynomial. So we know that coefficients are just the numbers that are out in front. So the coefficient of a term that was just y would have a coefficient of 1. 3y squared would be, the coefficient would be 3, and on negative 5y cubed, the coefficient would be 5. Identifying the degree of each term is really no different than identifying the degree of the monomial. So looking at the terms separately, if we could treat them all just like monomials. So this y would be degree 1. The next one would be a degree 2. This would be a degree 3, and this would be a degree 0 for the same reason that the 76 up top was. And that's because really there is no variable, so it's like saying it's x to the 0 power or y to the 0 power or whatever. Now when it asks you to write in standard form, remember we said that means that we want to put this in descending order of powers. So that means the highest power is going to go first. That's negative 5 y to the third is going to be your first term. And then it goes down from there, so plus 3y squared, then plus y, and then plus 10. And so when they ask me for that leading coefficient, that means that leading coefficient of the polynomial is 5. So now that we've established some vocabulary, let's go ahead and take a look at one of the operations, actually two of the operations between polynomials, and that's adding and subtracting. So we're going to go ahead and take a look at adding first. So I'd imagine that you recall from Algebra 1 doing some adding of polynomials, and you may remember the term like terms. And when we say like terms, when it comes to adding and subtracting polynomials, we mean that they have their terms that have the exact same variable or a combination of variables raised to the exact same powers. So in other words, like x squared could only be added with other x squareds. If I have an xy squared term, I could only add it with another xy squared term. So I'm always checking to make sure that they have the same variable or combinations of variables and same exponents on them. And if they are like terms, I can put them together by just simply adding their coefficients. So when you're adding polynomials, like we have here in this example A, that's the first thing I do is kind of scan through there and try to just find some way of identifying the ones that are like. So this one, 4x squared, there's an x squared here, there's an x squared here, and the 6x squared in the second term. There is a x cubed here, and there's no other x cubed over here. So in the second polynomial, there's not an x cubed. There's a constant term here, but there's no constant term in the second polynomial. There's an x to the fourth here, and maybe I do like a box on that one, maybe. Oops, my stylus is having trouble today, sorry. And on the other x to the fourth term over here, that plus 3x to the fourth. And then finally there's this just x to the first, and there's no other terms there to go with that. So now I'm going to go ahead and put my like terms together by adding the coefficients. And I always want to go in descending order of power, so I'm going to go ahead and start with the highest degree, those x to the fourth. So I have 5x to the fourth and 3x to the fourth. That makes 8x to the fourth. Then I'm going to move on, and as I usually do this, I usually cross them off. So then the x cubed. So I only see one x cubed term, and that's minus x cubed. So maybe instead of doing the plus sign, maybe I'm going to get rid of that and do a minus, but you could do also plus a negative, so minus x cubed. There's nothing to combine that with, so that one's done now. Cross that off. So now down to the x squareds. I have 4x squared and 6x squared. That makes 10x squared. And I'm going to cross those off. And then I have a minus x left here. Nothing to combine it with. And I have a plus 2 and nothing to combine that with. So my final answer is 8x to the fourth minus x cubed plus 10x squared minus x plus 1. So again, that's pretty straightforward. You just have to be aware of like terms and find some way of identifying so that you don't miss them. These polynomials get long and complicated. And so I used to try to do something like I did here with identifying them up front, which ones are going to be alike. So in this next one, I'm going to look for, you could also just do it this way. Like maybe you could just go say, okay, what's the highest degree I see? I see degree 4. So maybe I'm just going to go ahead and just look at the x to the fourth terms and combine them and then start crossing them off as I go. So I have a 6x to the fourth and a negative 7x to the fourth. That makes negative 1 or negative x to the fourth. So maybe you just do it like that. And then I looked, okay, are there any x cubed terms? Yep, I see a negative 18x cubed and a positive 2x cubed. So that makes a minus 16x cubed. So then maybe cross those off. And then is there any other x squared terms? Well, I don't see any x squared terms. So now I'm on to x's. There's an x here and there's a 10x here. And I'm adding. I always want to make sure I know what operation I'm doing. When I put those together, that makes 11x. And then those are gone. And then I have the minus 2. And I have the plus 5. Combine those together gives me a plus 3. And there's my final answer. And so by doing it in this way, I've got it in standard form, in descending order of powers. I can look right up front and see what the leading coefficient is. And anything else they would like to ask me about like that with degree and of the polynomial, it's always going to come from that first term then if it's in standard form. So let's go ahead and have a couple u tries. So what we're going to do with these is these are going to be the u tries, and I'm going to have you try them, and we're going to go over those when we get together in class. So we're going to go on and look at subtracting, but if you want to go ahead and pause the video now and try those while we're talking about addition, and then we'll come back to these and correct these in class. So let's move on. After you pause and try these, then you can tune back in, and we're going to talk about subtraction. Okay, so we know that subtracting is really just like adding the opposite. And so when we're subtracting polynomials, which I know I'm doing here because I see the subtraction sign, what I would really rather do is do addition, because we just saw that addition is really pretty easy. So I always like to take subtraction and turn it into addition of the opposite. And you know that makes it so when you get these really long, complicated polynomials that come after the subtraction, we don't forget that that subtraction applies to everything that comes after it. So I always just take a quick second at the beginning, change this to an addition, and everything after it, I'm just going to change the sign on. And now it all becomes addition, and it's the same skill we just talked about. So now we're going to go through, look at like terms, say like here are the x cubed terms. So I'm going to go ahead and add those together. 12x cubed and 18x cubed, and those again are the highest terms, so I started with those. That's 30x to the third. Those are done. I have a negative 8x squared and a positive a negative, almost forgot, almost missed it myself. I gotta do a better job of marking that. That was a negative 6x squared, so I have a negative 8x squared and a negative 6x squared. That makes negative 14x squared. And those are done. And now I have a positive 5x and a positive 9x, because when I distributed that negative through, that became a plus 9x, and that's 14x. And then finally the constant terms, I have a positive 19 and a negative 3, that makes positive 16. Okay, let's try another one. So again, anytime I'm doing subtracting, my very first step is to change to addition of the opposite. So I'm going to change this to a plus, and then everything that comes after it, I'm going to change the sign to whatever the opposite was it was, and these were all positive that came after the negative sign, so they all became negative now. So that's addition of the opposite, and now all I have to do is combine my like terms by adding. So again, if you want to kind of go through and find the highest degree terms, it looks like there's some x to the fifths. Although this looks kind of blurry on here, but that's a negative 5x to the fifth and a negative 10x to the fifth, which makes negative 15x to the fifth power. Oops. Fifth power, and then I'm going to cross those off. And then it looks like the next term down is x cubed, and there's no x cubed in the second polynomial, so there's just one in the first, so that's 8 plus 8x cubed. That one's done. Then I've got these x squared terms. They're both negative, so negative 4x squared and negative 2x squared makes negative 6x squared. And then positive 19 and negative 9 makes positive 10. So there's my final answer. And again, it's in standard form, leading coefficient, and highest degree out front. And as with the adding polynomial U-try questions, we're going to go ahead and I'll have you pause, try these, and then we'll talk about them in class. We'll correct and see how you did in class. And we're going to go on and take a look at our last learning goal, which is going to take a look at how this might apply to some real-life scenarios. So we'll go ahead and pause the video now and try 6 and 7 as your 2 U-try questions. And then we'll just go ahead and talk about them when we get to class. So once you're done trying those, tune back in, and we'll finish up our lesson. So our final learning goal is to be looking at how we can model with polynomial addition and subtraction. So this question asks us to find the polynomial that models the problem and use it to estimate the quantity. This is the data from the U.S. Census Bureau for 2005 to 2009. Shows the number of male students enrolled in high school in the United States can be modeled by this function right here, where x is the number of years after 2005, so that's important to know what x represents, and m of x is the number of male students. Okay, so the number of years after is being used to predict the number of male students in thousands, and then the number of female students is described by this polynomial. And again, x represents the number of years after 2005. And again, it's representing the number of female students in thousands. It says estimate the total number of students enrolled in high school in the United States in 2009. And so basically that's just the total number of students would be the males and the females added together. So this is kind of a lot of build up just to say, let's add these 2 polynomials together. So I'll go ahead and do that. So when I'm adding, again, I'm going to look for, it looks like they did write them in standard form, which is great. So I can just kind of go right down the line and add them in order. These are both x cubed terms, so when I add those together, they add up to negative 24.2 x cubed. Looking at the next term, so those are the x cubed ones are done, then the x squareds, I have a 55.3 x squared and a 74.2 x squared. That adds up to 129.5 x squared. So then we've got the minus 3.4x and the positive 141x, and those add up to 137.6x. And finally, those constant terms, 8,320.2 and 7,880 makes 16,200.2. So now how we're going to use that is it asks us to use this new polynomial function to estimate the number of students in 2009. And remember, x meant the number of years past 2005. So that means we want to find this new function, which they called total, and we want to do t of 4 because 4 years have passed. So we're just going to go ahead, plug 4 in for every one of these x values, and we can then estimate the value, or the total number, of students attending in high school in the United States in 2009. And so I'm going to go ahead, pause the video. I'm going to plug 4 in. You can feel free to do that as well on your own, but I'm just going to go ahead and substitute 4 in and see what I get. So I got 17,274, but remember that's in thousands. And so that's really like saying, if we just throw on 3 more zeros, and that means that 17,274,000 high school students in the year 2009. Okay, so this next example actually was going to represent a difference between the two. But I think the video is kind of getting a little bit long, and I think we kind of get the point. This one would be, we'd actually take this, we'd subtract because it has to do with the number of let's see, it says let n of x is the number of travelers in thousands. Estimate the total number of overseas travelers to Florida. And they said that it was modeled by, let's see, data from the U.S. Census shows that the total number of overseas travelers visiting New York and Florida can be modeled by this function. So this was the total. T of x was the total. And then they gave you n of x, which was visiting New York. And you could use the difference to find how many people must have been from Florida, or I'm sorry, visiting Florida. So we'll go ahead and skip that one, and we'll just move on to our final you try question. So this final one is going to be one for you to try. So you're going to have to figure out whether you're adding or subtracting, and take a look at this, another Census Bureau example. And we're going to have you try this one, and this will be another one that we'll go over in class when we see each other again. So go ahead and try this one. This is where the video ends, and we'll go ahead and talk about all the you try questions when I see you in class.